Hello, and welcome to converting recursive and explicit forms of arithmetic sequences. This is the last arithmetic sequence video. After this, I'll do some geometric sequence videos. Okay, so this is the big review of everything that we've done for the previous 8 Khan Academies that I've discussed in this little series. Just as a reminder, right here is the arithmetic sequence, just this thing. 7, 11, 15, 19, so on, so on. That's the arithmetic sequence. Everything else I've built around this is just to help you understand everything that these Khan Academies discuss. So what do we have? Well, we have some function notation over here, a sub n, or a of n. We have which term is it? Is it the first term, the second term, the third term? We have the common difference, and the common difference, as you might be able to see, is this reoccurring pattern in an arithmetic sequence. It's always adding the same number or subtracting the same number. So 7 plus 4 is 11, 11 plus 4 is 15, 15 plus 4 is 19, and so on and so forth. And then we have these two different types of formulas. We have the recursive formula, and the recursive formula says if you want the 8th term in the sequence, no problem. Make sure you know what the 7th term is and you know what the common difference is. So if you want the 8th term, you just take the 7th term and then you add this number to it. So that's the recursive formula. The explicit formula says maybe you want the 100th term, maybe you want the 1000th term. And if you want the 100th or the 1000th term, maybe you don't have the 99th term or the 999th term. You don't have the one right before it. So you want to be able to jump around within the sequence. Okay, so I'm going to share with you just the very basics of recursive and explicit, and then I'll do 2 of each style of question that is in this particular exercise. Okay, so for the recursive formula, on this Khan Academy, they're going to ask you some recursive formula questions, like what's a of 1? Well, a of 1 is this number right here. It is the first term. So I'm going to type in a 7 there, although I'm not typing at the moment. A of n equals a of n minus 1 plus something. And so they're going to ask you to write in another number here. This number that they want you to write in here is going to be that common difference. So I'm going to put in a 4. Again, just so that you understand what recursive formula means, this is the first, whoa, that wasn't supposed to happen. This is the first term of the sequence. And if you want a new term, like the 8th term, then all you need is the term before it. So if I'm going to call this a of n, then this term, the one before it, remembering that this is the number, would be called a of n minus 1. This is the term before it. The nth term is 8, so n minus 1 would be 8 minus 1, or 7. So if you want a new term, you take the one before it and add 4. Take the one before it, 41, and then add 4. 41 plus 4 is 45. Okay, so that's what the recursive formula does for us. The explicit formula says if you want any term at all, suppose you wanted the 100th term. If you want the 100th term, then you have to start off with our first term, like 7. And then you have to add to 7 a bunch of these common differences. And what you might remember from a previous Khan Academy is suppose that we wanted like the 6th term, right? If we wanted the 6th term, what happened there? Don't do that. Don't do that. I can't stop doing that. Okay, if you want the 6th term, then you would have to start off with the first term. And then for the 6th term, we would add in 1, 2, 3, 4, 5 common differences. So I would add in 4 times 5. 4 is my common difference, and I would need 5 of them. The 6th term needed 5 common differences. So The nth term would need a bunch of these 4s, but we'd only need n minus 1 of them. So the 6th term needed 5. The 100th term, if I wanted the 100th term, this number right here would be my first term plus a bunch of 4s. And how many 4s would I need for the 100th term? Not 100 of them. Remember, 6 only needed 5 of these 4s. 100 would need 99 of the 4s. 7 plus 4 times 99 would give us this number. And that's the explicit formula. It allows us to jump around. Okay, so 2 of each style now. Here's the first one. It says complete the recursive formula. So what I'm looking at right now is they have given me this information, and that information is the explicit formula. I rewrote it down here. So the first thing I'm going to do as I'm thinking about this is I'm going to be remembering what we just talked about with the explicit formula. That this number up front means that's my starting amount. And then this number right here is telling me how I'm moving. And so on and so forth. So I am just pulling out the information I need from the explicit formula that they gave me. Okay, complete the recursive formula for f of n. So f of 1 equals, okay, that was actually given to me. I'm going to write in negative 11. And for the recursive formula, f of n is f of n minus 1 plus. So again, if I'm calling this one f of n, then f of n minus 1 would be this guy. And so I would take this number, and to get to here, I would have to add in my common difference. So it's basically, if you just want to keep it as simple as possible, look up into the formula and know what to extract to put down in the boxes down below. But to have a larger understanding of this, we're trying to read this formula, this explicit formula right here that is provided for us. And as we learn to read this, then we can extract that and give ourselves the recursive formula. Okay, one more of these, maybe a little bit quicker. I tend to talk a lot. Okay, so as I'm reading this, I'm thinking my formula is going to be 25 is my starting point. And then I'm taking away 49. To get to each new term within my sequence. So this one is going to have smaller numbers. 25 minus 49 is going to get me into the negatives, and then I'm going to keep being in the negatives over and over again. Okay, so my first term is 25, and to have a recursive formula, I need the previous term plus my common difference, and so that's going to be a minus 49. All right, so we've done 2 of those, which was complete the recursive formula. And now we're going to find an explicit formula. So we're just going to do the opposite. Okay, so as I'm looking at this information right here, I now want to, that is an ugly box. I'm going to go ahead and think about the sequence. So this sequence says f of 1 is negative 8. So I'm going to put a negative 8 right here. And to get a new term, I take the one before it and I subtract 3. So it looks like I found my common difference. Negative 8 minus 3 is negative 11, minus 3 more, negative 14, minus 3 more, negative 17, and so on and so forth. So how do I find my explicit formula? My explicit formula is always going to be this, oh, it's not A, it is F. I'll just change that to an F. F of n equals the first term. So the first thing I'm going to write is F of 1, and then I'm going to add to that my common difference times n minus 1. And I'm actually going to write this n minus 1 in parentheses. When I write this in here, it's actually going to have the n minus 1 thought. And I'll explain that again in a minute. So I'm going to go ahead and write in exactly right here what you would have to type into Khan Academy. It would be my first term. So I'm going to write in negative 8 plus my common difference, which I saw up here was a minus 3, times n minus 1. So that's exactly what I would write in Khan Academy. Now, personally, I don't ever like writing plus a negative. You know me, and that's not my style. I would actually write in -8 minus 3 times n minus 1. It's faster, and I don't trust all of the mechanics of websites. So I would be a little hesitant to want to sort of gamble that Khan Academy was going to understand plus a negative meant the same thing as minus. It does. I've checked it, but that's just me. I like to keep it clean and simple. Okay, so one more of these and the video is over. So here we have it. G of 1 is 51. Okay, that's my first term. My recursive formula says if I want a new term, I take the previous term and I add 2. So I would think about my my sequences being like this. 51 plus 2, plus 2 again, plus 2 again, and so on. So what's my explicit formula look like? It looks like this. G of n would be the first term plus a bunch of 2's. How many 2's do I need to get to my nth term? I need n minus 1 of those 2's. So 51 plus a bunch of 2's, n minus 1 of those. And that's what I would type in. Okay, that's all. I wish you luck when next we meet geometric sequences. Dun dun dun.